This week, you're going to learn how to do a hypothesis test, which is basically a series of steps to test a claim that's made about a very specific population. So, do you guys remember the freshman 15 study where we wanted to know if college students actually gained 15 pounds at the end of their freshman year? So, here we can actually test that claim by doing a study, getting some sample data, and using that data as evidence to either say that this is true or this is not true. So the population that we're looking at here is the population of weight gain or weight loss for all freshman students, and we look at the average. So what is the typical amount of weight that students either gain or lose during their freshman year? So let's let mu be the mean weight gain measured in pounds, okay, for all freshman students, okay? Then we can write what's called a null and alternative hypothesis, written as H sub 0 and H sub 1, where the null hypothesis is our working assumption, the assumption that freshman students do gain 15 pounds. So we always assume that this is true. That's the null hypothesis. And then our job is to gather evidence to kind of test against that to see if that's the case. So the alternative hypothesis is literally that. What is the alternative if students don't gain 15 pounds? Well, they can either gain less than 15 pounds or more than 15 pounds, but we need a mutually exclusive statement, so I can simply just write it as not 15 pounds. Okay, so what does a hypothesis test do? A hypothesis test says, if the null hypothesis is true, so if students do gain 15 pounds, then we expect that every time I take a sample from the population, so I'll draw a big bubble here for the population where it contains a bunch of X's, and each X is the weight gain or weight loss of a freshman student. Now, I cannot draw enough X's to represent every single freshman student, but assume that that fits inside that big bubble. Okay, so again, I can't really work with population data because that's very hard to survey the entire population. But what we can do is we can take a sample from the population. So if you guys recall the freshman 15 study, the authors took a random sample of 125 students, and then they calculated the average weight gain for those 125 students. Okay, every time that we take a sample from the population, if the null hypothesis value is true, then we expect the mean value to be 15 pounds if that's true, and it should occur at a high frequency. So again, if the null hypothesis value is true, then every time I look at a sample from the population, I should expect that average weight gain to be 15 pounds. But we know that with random samples, we could get different sample mean values, meaning different X bar values. So I could end up with a average weight gain of something bigger than 15 or something less than 15, okay? But we learned that in chapter 6, anytime you look at a sampling distribution of sample means, that distribution is normally distributed, so it's bell-shaped, where we have lower frequencies in the tail of the distribution, okay, and higher frequencies at the center of the distribution. So that freshman 15th that I'm going to use green here, it turns out that from their sample, students only gained 2.7 pounds. Okay, so where does that X bar value fall on this distribution? It most likely will fall in the left tail here because 2.7 pounds is far away from 15. So we can be subjective and say, man, 2.7 pounds, that's really far away from 15 pounds. But again, we can't use our subjective feelings. So we have to be more objective. So objectively, we can calculate the probability of getting a sample mean value of 2.7 pounds. And in this study, the authors actually found out that the probability of getting that value is really small. So we say that the results of this study is statistically significant. It's telling us that the difference between 2.7 and 15 pounds is significantly different. So because it's significant, it's enough for us to conclude that freshman students most likely do not gain 15 pounds. So this, it turns out, is not true. So we can reject this claim, not true, reject our null hypothesis claim, and conclude that freshman students probably gain less than 15 pounds, more likely something close to 2.7 pounds. So this is a really fun thing to be able to do, is to test claims made about a population. So I hope you have fun with it this week.